Hi friends, I welcome you all for this video. This is basically on Fourier Transform. A small introduction about Fourier Transform. Here let us abbreviate Fourier Transform as FT. What is in Fourier Transform? And what is it? It is just a mathematical method using the trigonometric function sine and cos. What does it do? Fourier transform convert time domain into frequency domain. So all time domain spectrums are converted into frequency domain spectrum, right? Sine and cos are key to the success of Fourier transform because sound represented by the complex combination of their waves, and waves are like sound waves will be in sine curve as well as cosine curves, right? Let's do this game. It is a noise exercise game. The game is very simple. Everybody open up a page or something. They can read it very loud as much as possible in a room, classroom, anywhere. Okay, in that crowd I will call a name randomly. The person whom I called, he should shout stop from the crowd, right? From the noisy environment, right? When you do this exercise, the one whose name is called can easily recognize his name alone in that noisy environment. That is very simple, called as Fourier transform. Day to day life, technically humans very easily perform Fourier transform mechanically almost every day, every minute, every second, right? In Fourier transform nuclear magnetic resonance spectroscopy, free induction decay FID is the observable NMR signals. This is the application of Fourier transform, right? The learning objective of this video is understanding Fourier transform and its application in mobile phones, cell phones, MP3s, and nuclear magnetic resonance, etc. Here time domain is converted into frequency domain. That is very important learning objective of this Fourier transform, right? Now all engineering students are aware about cosine waves and sine waves. Now you take a paper and draw a cosine wave. You get this, right? You can see what is cos 0 is 1, cos 90 is 0, cos 180 is minus 1, and so on. You get this curve. As well as you can draw sine curve, sine wave. Yes, you get this 0 1 minus 1, 0 1 0 minus 1, this curve, right? I have drawn here. Now we are going to take a test curve, test signal. Take another cosine wave for test signal, right? I am taking a cosine wave, and what I do is, now I try to multiply summation of different signals, so I get different waves. I multiply the signal 1. What is our first signal? Signal is cosine wave. Again I multiply with the test signal, that is again a cosine wave. What wave did I get? Everything becomes in positive side, so there is no negative waves here. So all are in positive side. See this, all are in positive sides. There is no negative. So when I do the multiplication with signal 2, that is sine wave and cosine wave, you get this, right? Different types. So I get different signals and different waves. Different. When I do multiplication, plenty of negative and positive waves. See here, I get different type of signals. When I do summation, cancels out. No signals are observed here. See, like this I can do and get a steady increase in the integration of the multiple curves. See here, the different curves I generate due to multiplication and summation. I have put everything in Excel, and I just show you a screenshot here. See how do I do? I have taken the frequency, time, amplitude, phase, etc., and put up in, and the values are easily described, and it is made in a Excel sheet, right? Different values, different type of signals are different type of signals you get. See this, a human ear can hear 20 to 20,000 hertz. A human ear is capable of hearing frequency range in between 20 to 20,000 hertz. As we get older, we lose the ability of hearing low and high frequencies. So when you get older, you obviously lose your hearing capacity. That means the high frequency you are not able to hear, as well as low frequency. Highest 20,000 hertz and 20 hertz, low as well as high. For example, young people are capable of hearing frequency close to 20 and 20,000, whereas old people are not. Very simple. So the warning message for youngsters, what is the warning message? People who frequently use MP3s, be careful. Eventually you have higher chance of losing your hearing. Right? Let's see what is ultrasound and infrasound. When I say infrasound, any sound with frequencies below the range of our hearing, that is human hearing, less than 20 hertz is known as infrasound. And any sound with frequency above the range more than 20 hertz is called as ultrasound. Right? Sound Fourier transform. Higher sound, higher frequency. Higher sound, higher frequency. And I say lower sound, lower frequency. So my voice is getting higher sound, the pitch increases. When I say lower sound, my pitch decreases to the lower sound. Right? You can also try it. You can, the female voice is higher sound, higher sound, and you say lower sound, lower sound. Right? So higher frequency produces more cycles. Cycles are produced more in higher frequencies. When I say lower frequency, it produces very less cycles. For example, thunder, a frequency of just 50 hertz, maybe maximum 100 hertz. You can hear the thunder sound. Go out one day, okay? Stand outside and you can hear the thunder sound, okay? On the rainy season, not on the summer season, right? Whistle can have a frequency of 1000 hertz. Okay, you can blow the whistle and see, you can hear the frequency is very high in the whistle. You can practice it. I hope you know how to whistle, right? Yes or no? Right. Okay, now let's see what is amplitude. Amplitude is volume on your mobile phone. Okay, you take your mobile phone and turn the volume. You can increase the volume as well as you can decrease the volume, right? So if you increase the amplitude of the sound, means you are making the mobile phone louder. You can increase the sound. That is nothing but your amplitude is increased. If you decrease the amplitude, you are making the sound softer, or you making the sound less, right? If you keep your mobile phone in louder sound, your speaker will be doom as soon. Okay, musicians, the word that musicians use for frequency is pitch, right? I have a guitar with me. So in guitar you have 6 strings. Can you hear these sounds? This is the first string, E, B, G, D, A, and again E. So the difference is, this is E, the pitch is high, and this is also E, the pitch is low, right? Right? So I combine both the strings, E, top E as well as base E, right? Okay, now let's go to the other. The shorter the wavelength, this is very important. The shorter the wavelength, the higher the frequency. So what do you mean by this? When I give the string E, it means that shorter the wavelength, the vibration, the shorter the wavelength, and higher the pitch of the sound. The pitch is higher. In other words, shorter wavelength, pitch high, longer wavelength, pitch low. Okay, right? This is the last point. Is telephone companies are seeking for a specific bandwidth for their customers, so they need to compact lot of data in a very small amount of space, right? This is very important. So the companies are searching for a lot of data to be stored in a very small amount of compressing, right? This is what they need. Let's do this voice test. Each student, let them say hello, right? I have two sample. One sample I have record female voice with highest sound and male voice with lowest and deep sound saying hello. Analyzing their voice using Fourier Transform program, which proves female voice is with higher pitch than male voice. It means female voice have high frequency than male voice. When I compare whistle and female voice, whistle has a higher pitch than female voice. The pictures are here. Female voice with higher frequency. The frequency is very high. You can see the frequency here, 19050. And when I see male frequency, it is less. When I see the voice, the frequency of whistle, it is high, 19850. That is 050, and this is 850. The frequency here is high for the whistle. So the conclusion here is the Fourier transform converts the time domain spectrum into frequency domain spectrum. So when you see a problem, what we do is we convert the time domain spectrum X to S, time domain spectrum. Thank you. Thanks for watching this video.